Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi there, Herman and Corn. We have been chatting in recent episodes much about data centers. We're used to thinking about the cloud in the abstract. When we upload something to Google Drive or we send a message, it does go somewhere to store. Even though data has become so abstracted, everything has become abstracted. Kubernetes, containers. I'm sure that the global infrastructure network that Google or AWS manages is likewise, but nevertheless, for a millisecond or part of a millisecond, if we pause time, and we'd firstly see the insane journey across the bottom of the ocean that our data makes, but it would eventually wind up in a building, and in this imaginary moment, we could ask the manager of this data center, hey, we just uploaded a file to Google Drive. Do you know what computer that lives on? And it would be in some box in some row. So there is a physical element to data, even if it's totally abstracted. But that involves a huge amount of space, power, and electricity. We've talked about how the data center has rapidly shifted from being an aggregator of compute and storage, compute in the sense of traditional CPU compute, and moved over to optimizing for VRAM in the era of AI, GPU inference. And those are really power hungry and noisy, and just a lot of physics is required to cool these things. So that's very quickly shifted the discourse around data centers into the realm of sustainability. And if we're talking about scaling AI, this is the back end of the infrastructure that we need. One question that I had, Herman and Corn, in our discussions about distributed computing, we talked yesterday about the blockchain and fascinating projects like the interplanetary file system and Arweave. And I mentioned that I wouldn't say I'm hopefully not just a total conspiracy theorist, but I would say I'm more in the category of a digital worrywart, in the sense that if I create something I'm really proud of, and I have to say I put this podcast very high, if not on the top of my list, and I love these episodes dearly. Now, what am I worried about when that, it's not actually that Vercel will fail, it's that I'll screw up somehow and manage to get locked out of the wasabi bucket, or forget to miss an email that says you have an expired credit card on file, and I'll try to log in Monday or my friend someone will send me a WhatsApp saying, hey, Dan, what happened to my word prompts? And I'm like, oh no, it's gone. That's the doomsday scenario that I'm always trying to mitigate against. And when I'm talking about stuff like IPFS and distributed storage, that's usually where I'm coming from. It's this idea that we have a node of important data spread out over a network, and you don't have that chance of a single point of failure. So that's my angle for being a backup fiend. But Herman and Corn, if we talk about the huge footprint of these things, of data centers, and some of the advantages of sharding our data, never a word that sounds very normal in a sentence, I sometimes think, well, couldn't we just, instead of centralizing data in these big data centers operated by these mega hyperscalers, couldn't we aggregate all of our compute around the world and just have an internet where the actual storage backing the network, all the resources, are just globally distributed? So I told my wife I was going to send in a prompt about this, and she said, oh, you mean like Pied Piper? So I'm a big Silicon Valley fan, you won't be surprised to hear, but I totally forgot that, and she was spot on. Thank you, Hannah. She said the startup in Silicon Valley was called Peer Piper, and the core idea was a decentralized peer-to-peer internet infrastructure built on a highly efficient compression algorithm created by Richard Hendricks. So the first thing I said to my wife was, well, hang on. the internet is vast. We're talking about exabytes. If we couldn't have a node-based network where the sum of any one node is vastly smaller than the cumulative sum of the data that needs to be distributed around the node. So if someone wanted to pull an episode of My Word Prompts, a couple of gigs of data for all our episodes so far, that would have to come from someone who had that on their node. So my question, Herman and Corn, and sorry to be so verbose, but I wanted to get in all the different points that I'm looking at this from. Could this peer-to-peer network actually be a reality? We would need to basically figure out a way to rethink the cloud from being based around this hub and spoke model of a few hubs and billions of spokes feeding in data, to one where it's a node-based model where we just move around little amounts of data. And sorry to ask such a dumb question, but the other thing I always think about when I hear about this idea is, okay, your average computer user, you might have 16 gigs of RAM. You don't want 15 of those gigabytes to be taken up by a background process that is moving around everyone else's data. So we need to have computers, this syncing and node-based process would need to be light enough. And what happens, another question I have, what happens if you end up moving around criminal data? You're just a node in the network. For security reasons, you can't see what is coming in and out of your node. And this is a broader question about blockchain. If that turns out to be illicit content of some kind, have you just become complicit in a crime? Herman and Corn, let's talk about the practicalities of a truly node-based internet in today's episode of My Word Prompts.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I am sitting here in our living room in Jerusalem. It is a beautiful, surprisingly crisp February afternoon in 2026. The sun is hitting the stone walls of the old city in the distance, and I am here with my brother, the man who has probably read more white papers on distributed systems and consensus protocols than anyone else I know.
Herman Poppleberry here. And honestly, Corn, that is probably a fair assessment. I spent my morning looking at the latest benchmarks for decentralized storage protocols and some of the new peer-to-peer telemetry coming out of the European research hubs, so this prompt really hit the sweet spot for me. It is good to be back in the hot seat.
It really is. Today's prompt comes from Daniel, and it is a concept that feels like it has jumped straight out of a television show, but has some very real, very heavy implications for how we build the future of the internet. Daniel wants to talk about the idea of a truly peer-to-peer network, essentially aggregating the world's spare compute and storage into a distributed, node-based system.
Right, the P. Piper model. For anyone who has seen the show Silicon Valley, that was the big dream, right? A new internet where data lives on our phones and laptops instead of in these massive, power-hungry data centers owned by a handful of tech giants. It was a comedy, but the engineering principles they discussed, compression, distributed hash tables, mesh networking, those are very real fields of study that have advanced significantly in the last couple of years.
And the timing is interesting, because we have been talking a lot about data centers lately. Specifically, how the shift toward artificial intelligence and these massive graphics processing unit clusters is changing the physical landscape of the web. It is not just about storage anymore. It is about massive concentrated bursts of heat and electricity. We are seeing reports from late 2025 showing that data center energy consumption has nearly doubled in some regions just to keep up with large language model inference.
Exactly. We have moved past the era where a data center was just a bunch of central processing units humming along at a steady state. Now, we are seeing these specialized facilities optimized for tensor processing and high bandwidth memory. The energy requirements are staggering. We are seeing single facilities pulling hundreds of megawatts, sometimes straining local grids to the point of failure. So, the question Daniel is asking, whether we can offload that massive load to a distributed network of consumer devices, is not just a geeky thought experiment anymore. It is becoming a question of global sustainability and infrastructure resilience.
But let us look at the practicalities here, because Daniel raised some really pointed questions. If we are moving away from the hub and spoke model, where Google or Amazon is the hub and we are the spokes, and we move to this mesh where everyone is a node, the first thing that comes to mind is capacity. Herman, the internet is measured in exabytes now. How on earth do you fit that onto consumer hardware?
That is the first big hurdle. When we talk about exabytes, we are talking about 1 billion gigabytes. To put that in perspective, your average smartphone in 2026 might have 512 gigabytes, or maybe a terabyte of storage if you bought the high-end model. Even if you have 1 billion users, you are asking each of them to give up a significant chunk of their personal space. But the way architects of these systems, like the people behind the Interplanetary File System or Arweave, think about this is through a process called sharding and erasure coding.
Right, sharding. We have touched on this before, but let us refresh. Instead of one person hosting the whole file, you break it into 1,000 tiny pieces and spread them out?
Precisely. You take a file, you encrypt it, you break it into shards, and then you distribute those shards across the network. But here's the technical nuance. You use something called Reed-Solomon error correction. It is the same math that lets a scratched compact disc still play music. You do not just split a file into 10 pieces, you split it into, say, 30 pieces, but you only need any 10 of them to reconstruct the original.
So you build in a mathematical safety net.
Exactly. But here is the catch, and this is what Daniel was touching on with the node-based model. You cannot just have one copy of each shard. If I have a piece of your photo on my phone and I go into a tunnel or my battery dies, that shard is gone. In a peer-to-peer network, nodes are churning constantly. People turn off their computers, they lose Wi-Fi, they drop their phones in toilets.
So you need massive redundancy. You need 10 or 20 people hosting that same tiny shard so the file stays available 24/7.
At least. And that is where the math starts to get difficult for a Pied Piper-style internet. If you need 20 times redundancy to ensure that a file is always accessible with 99.9% reliability, you have just multiplied the storage requirements of the entire internet by 20. Suddenly, that exabyte of data becomes 20 exabytes of traffic and storage. Can a peer-to-peer network of phones and laptops actually handle that volume without just falling over under the weight of its own metadata?
It feels like a massive efficiency trade-off. We talk about the cloud being efficient because of scale, right? Amazon can pack thousands of enterprise-grade drives into a single rack with shared liquid cooling and high-efficiency power delivery. If we distribute that, aren't we just moving the inefficiency to the edges? Instead of one big fan, we have 1 million tiny, inefficient fans spinning up in people's living rooms.
In terms of raw thermodynamic efficiency, the centralized data center wins every time. It is much easier to cool one giant room than 1 million small ones. But the argument for decentralization is not always about raw storage efficiency. It is about the cost of the middleman and the risk of centralization. If Amazon Web Services has an outage in their US East 1 region, which we saw happen several times in the early 2020s, half the internet breaks. In a truly distributed node-based system, there is no single point of failure. The network is fundamentally more robust. But you are right, the overhead of managing that distribution, the gossip protocols, required just to keep track of where those billions of shards are, is a massive technical challenge that we are still trying to solve.
I want to dig into the local hardware impact that Daniel mentioned. He made a great point about random access memory and processing power. If I am a node in this new internet, my device is constantly working in the background. It is routing traffic for my neighbors. It is serving up shards of other people's data. It is verifying transactions on a ledger. If I have 16 gigabytes of memory on my laptop, I do not want a background process eating up 12 of them just to keep the neighborhood's internet running.
That is a very real concern, and it is one of the reasons why early peer-to-peer projects like early Ethereum nodes or IPFS nodes were mostly run by enthusiasts with dedicated hardware. Current protocols can be quite resource-intensive. If you run a full node today, you will notice your fans spinning up and your memory usage climbing because the node has to maintain a routing table of all its peers. The Pied Piper dream relies on something we do not quite have yet, which is ultra-efficient, low-overhead background protocols that can operate on the scraps of our hardware.
It is like the SETI at Home project from years ago, or Folding at Home, where people would let their computers search for signs of extraterrestrial life, or fold proteins while they slept. But that was voluntary and occasional. This would be constant.
And it is not just memory, it is battery life and hardware longevity. Think about your phone's flash storage. It has a limited number of write cycles before the hardware literally wears out. If your phone is constantly writing and deleting shards of other people's data, you could burn through the lifespan of your phone's storage in a year instead of 5 years. We would need a fundamental change in how hardware is manufactured, perhaps dedicated P2P partitions on our hard drives that are designed for high-frequency cycling.
And what about the mobile operating systems? Right now, Apple and Google are very aggressive about killing background processes to save battery. If I am running a node on an iPhone, iOS is going to kill that process the second I switch to Instagram.
Exactly. A node-based internet is essentially the opposite of the current mobile philosophy. It requires the device to be always on and always participating. Unless Apple and Google build these protocols directly into the kernel of the operating system, a true phone-as-a-node network is going to struggle with massive churn as apps get throttled.
So, maybe the phone as a node idea is a bit of a stretch for now, but what about home hardware? Everyone has a router. Many people have smart home hubs or even old laptops sitting in a drawer. Could we see a world where we have dedicated node boxes in our homes that handle this?
That is much more likely, and it is actually where the industry is heading. We are seeing the rise of DePIN, decentralized physical infrastructure networks. These are companies that sell you a little box, maybe the size of a sandwich, that plugs into your router. It has its own processor, its own storage, and it earns you cryptocurrency or service credits in exchange for providing storage or compute power to a decentralized network. It is essentially a plug-and-play node that solves the battery problem and the memory on my main laptop problem. But it still does not solve the bigger issue Daniel raised, which I think is the most terrifying part of this whole concept for the average person.
You mean the legal implications?
Exactly. The illicit content problem. This is the dark side of the Pied Piper dream. If I am a node and I am hosting shards of data that are encrypted, I have no idea what is on my hard drive. I could be hosting bits and pieces of something truly horrific, or stolen state secrets, or copyrighted material that a studio is aggressively litigating. If the authorities raid my house and find those bits on my drive, am I liable?
This is where the technology and the law really clash. In a centralized system, the responsibility is clear. If Google is hosting something illegal, you send a takedown notice to Google. If they do not comply, they are in trouble. But in a peer-to-peer network, who do you sue? Do you sue 10,000 individual node operators who do not even know what they are hosting?
It is a legal nightmare. Current laws like Section 230 in the United States or the Digital Services Act in Europe provide some protection for intermediaries. They say that the platform isn't responsible for what the users post. But those laws were written for companies like Facebook or Twitter. If I am a node, am I a platform or am I just a piece of the infrastructure? If I am hosting the actual data, even if it is encrypted and I cannot read it, the legal precedent is very thin.
I imagine a prosecutor would argue that by choosing to run the node and accepting whatever incentives come with it, like those tokens you mentioned, you are taking on the risk of what that node contains. It is like agreeing to store a locked suitcase for a stranger in exchange for $5. If that suitcase contains something illegal, the "I didn't know what was inside," defense only goes so far in many jurisdictions.
Right. It is called willful blindness. And this is why a lot of these decentralized projects are focusing so heavily on zero-knowledge proofs. They are trying to create a technical environment where it is mathematically impossible for the node operator to know what they are hosting, and more importantly, they are trying to build provable deletion or filtering at the protocol level. But the law moves much slower than the code. We are still litigating things from 20 years ago while the technology is moving into 2027 and beyond.
And what about the bad actors? If the network is truly peer-to-peer and decentralized, how do you stop it from becoming a safe haven for things that society has collectively decided should not be hosted? In a centralized web, we have content moderation. It is imperfect, and we talk about its flaws all the time, but it exists. How do you moderate a mesh network?
That is the million-dollar question. Some people argue that you cannot moderate it, and that is the whole point. It is censorship resistant. But total censorship resistance means you have to accept the worst parts of humanity alongside the best. Other projects are looking at reputation-based systems where nodes can choose to only peer with other nodes that follow certain community standards. But then you are just recreating centralization on a smaller scale. You are creating walled gardens of nodes, which kind of defeats the purpose of a global, unified internet.
It feels like we are at this crossroads where the current model is becoming unsustainable because of the sheer power and cooling requirements of these massive AI data centers. But the alternative is this chaotic, legally murky, and technically inefficient web of nodes. Is there a middle ground?
I think the middle ground is what we are starting to see with edge computing and fog computing. Instead of every individual phone being a node, we have smaller, localized data centers at the neighborhood level. Maybe your local internet service provider has a rack of servers at the end of your street, or even inside a 5G base station. It is still the cloud, but it is much closer to you. It reduces latency, and it distributes the heat and power load more than a massive hyperscale facility in the desert does.
That makes a lot of sense. It is like the difference between one massive warehouse for the whole country and 100 small corner stores. You get some of the benefits of decentralization like speed and resilience without the chaos of a pure peer-to-peer system where my neighbor's cat video is stored on my refrigerator.
Exactly, and it allows for better management of the hardware. You can use industrial-grade hardware that is designed to be on 24/7 rather than relying on someone's old MacBook Pro that might catch fire if it runs at 100% CPU for too long.
Let us go back to the Pied Piper idea for a second, specifically the middle-out compression part. In the show, the whole thing worked because they had this magical algorithm that made files tiny. In the real world, how much of this problem is actually a compression problem versus a storage problem?
Compression is always part of the equation, but we are reaching the limits of Shannon's information theory. There is only so much you can squeeze a file before you start losing information. The real breakthrough we need is not necessarily better compression, but better data orchestration. How do we move data around the world so efficiently that it feels like it is local, even if it is stored in shards across 3 different continents?
That brings us to latency. Daniel didn't mention it specifically, but it is the elephant in the room for any node-based internet. If I want to watch a high-definition video, and my computer has to fetch shards from 50 different home internet connections, each with its own upload speed and jitter, isn't that going to be a terrible experience compared to streaming from a dedicated Netflix server?
Oh, absolutely. If you tried to run today's web on a pure peer-to-peer network without some serious caching and orchestration, it would be agonizingly slow. This is why projects like Filecoin or BitTorrent work best for cold storage or asynchronous data. It is great for downloading a large file that you do not need right this second. It is much harder for real-time applications like video conferencing or high-end gaming. For those, you need the edge nodes we talked about, servers that are physically close to the user and connected by high-speed fiber.
So, maybe the new internet isn't a replacement for the old one, but a parallel system? Like, we use the centralized web for our high-speed real-time needs, but we use the decentralized node-based web for archiving, for privacy-sensitive data, or for long-term storage where we do not want to be beholden to a single company's pricing.
I think that is the most realistic path forward. We are already seeing a hybrid web. Think about how many people use a centralized front end like a website, but the actual data is being pulled from a decentralized backend. It is about using the right tool for the job. If you are a journalist in a country with heavy censorship, a peer-to-peer node is a lifesaver. If you are just trying to watch the latest blockbuster movie in 4K, you probably want a centralized content delivery network.
I want to touch on the economic side of this too. Daniel's prompt implies a sort of collective aggregation of resources. In the show Silicon Valley, they talk about it as a democratic internet. But for this to work at scale, people need an incentive to keep their nodes running. If I am paying for electricity and my hardware is wearing out, I want to be compensated.
And that is why almost every modern decentralized project is tied to a cryptocurrency or a token. You earn tokens for providing storage or compute, but that introduces a whole new set of problems. Suddenly, the democratic internet is driven by market speculation. If the price of the token drops, people turn off their nodes because it is no longer profitable to pay the electricity bill. If the nodes turn off, the data disappears.
It is a fragile ecosystem. It relies on a perfect balance of technical reliability, legal protection, and economic incentive. If any one of those 3 legs of the stool breaks, the whole thing collapses. We saw this with some of the early play-to-earn or share-to-earn models where the economy just wasn't sustainable.
It really does. But I do not want to sound too pessimistic. The reason people like Daniel are asking these questions, and the reason developers are still banging their heads against these problems in 2026, is because the current system has some very scary failure modes. We are seeing increasing censorship, massive data breaches, where hundreds of millions of records are stolen from a single central server, and a concentration of power that is unprecedented in human history. A node-based internet is the break glass in case of emergency option.
It is the ultimate insurance policy. If a major government decides to turn off part of the internet, or if a massive solar flare knocks out a primary data center hub in Northern Virginia, a decentralized network might be the only thing left standing. It is about survival as much as it is about efficiency.
Exactly. It is about resilience. Even if it is slower, even if it is more expensive, the fact that it can't exist is a powerful check on the power of centralized entities. It forces them to be better because they know there is an alternative, however clunky it might be.
So, let us look at some practical takeaways for our listeners. If someone is listening to this and thinking, I want to be part of this node-based future, what can they actually do today?
There are a few things. You could look into running an IPFS node. It is relatively easy to set up on a desktop computer, and it lets you participate in a distributed web. You can look at projects like Filecoin or Arweave if you have extra hard drive space and want to see how the incentive models work. But more than that, I think the takeaway is to be mindful of where your data lives. When you upload to the cloud, you are really just putting your data on someone else's computer.
Right. It is not an abstract cloud. It is a physical building in Virginia or Ireland or Singapore, and that building has a landlord, and that landlord has rules, and those rules can change.
Exactly. Understanding that physical reality is the first step toward appreciating why decentralization matters. Even if we never get to a pure Pied Piper world where every phone is a node, the move toward a more distributed, edge-heavy internet is already happening. It is a response to the physical and political limits of the current model. We are seeing sovereign clouds being built by countries that want to own their own data infrastructure.
I think the legal part is what I will be watching most closely over the next year. As more people start running these DPM boxes in their homes, we are going to see some very high-profile court cases. Someone, somewhere, is going to get in trouble for what their node is hosting, and that will be the Napster moment for the decentralized web. It will define the rules for the next 20 years.
I agree. The technology is almost there. We have the bandwidth, we have the encryption, we have the sharding math, but the social and legal frameworks are lagging far behind. We are basically trying to build a 21st century infrastructure on 19th century legal foundations. It is going to be a bumpy ride.
It is a fascinating tension, and it brings us back to why we do this show. Daniel's prompt forced us to look at the intersection of physics, law, and software. It is not just about, can we do it, but should we do it, and what happens when it goes wrong.
And honestly, that is the most weird prompt thing about it. It starts with a fun idea from a TV show and ends with us questioning the nature of liability and the future of global infrastructure. It is all connected.
Well, Herman, I think we have thoroughly explored the node-based rabbit hole for today. I'm still not sure I want my phone's battery dying because someone in another country is downloading a cat video, but I can certainly see the appeal of a more resilient, less centralized web.
I will keep my node running in the background, Corn, just in case the big one hits the data centers.
Of course you will. You probably have 3 running right now under the coffee table. Before we wrap up, I want to say a huge thank you to Daniel for this prompt. It really pushed us to think about the physical reality of the internet in a way we haven't in a while.
Yeah, it was a great one. And hey, if you are enjoying these deep dives into the weird and wonderful world of technology and beyond, we would really appreciate it if you could leave us a review on your favorite podcast app. Whether you listen on Spotify, Apple Podcasts, or somewhere else, those ratings really help new listeners find the show.
It genuinely makes a big difference. This has been My Weird Prompts. You can find all our past episodes and a way to get in touch with us at our website, myweirdprompts.com. We have an RSS feed there for the subscribers, and a contact form if you want to send us your own thoughts on the node-based internet.
Or you can just email us directly at show@myweirdprompts.com. We love hearing from you, especially if you have a different take on the legal or technical challenges we talked about today. Maybe you are a lawyer who specializes in distributed systems liability. If so, we definitely want to talk to you.
Absolutely. We are all about that collaborative exploration. Well, that is it for this episode. From Herman and myself, here in Jerusalem, thanks for listening.
Until next time, stay curious.
Goodbye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.